So we'll start with questions on Surds. So go straight to examples. Rationalize the denominator. A 2√3 minus √2. We divide by 3 minus 2√12. And B 4√7 plus √3 over 3√7 minus √3. And C 3 plus √2 over 1 plus 2 √18 minus 2 √2. Okay. So that's the three examples under rationalization of the denominator. Let's see how we do things. For the first one, the denominator is 3 minus 2√12. So we can try to see if we can reduce that √12. So we can write √12 as the root of 4 times 3. Now, under roots, we can separate them if we are doing multiplication. So this can be √4 multiplied by √3, meaning the root of 4 is 2, so we'll have 2 multiplied by the root of 3, which we don't know. And since that 12 has a 2, it's being multiplied by 2, so we'll multiply by 2, we'll multiply by 2, which will make it 4√3. That 2 does not multiply inside the root. It multiplies the coefficient of the root. So that's how we get a 4√3 there. So when we come back to our question, it will now be 2√3 minus √2 over 3 minus 4√3. And then now we can rationalize. So we multiply by the denominator 3 plus 4√3. Whatever you do to the denominator, you do the same in the numerator. So even here, you multiply by 3 plus 4√3, like that. So you multiply by the same thing that we have used in the denominator to the numerator. So you don't make something out of the numerator, you make something out of the denominator first and use it for both. So now we multiply 2 times 3, we get 6 multiplied by the root of 3. So we won't multiply the root directly. We'll be multiplying the coefficients unless we find that the inside of the roots are equal. At that point, we can multiply. Like now, so now we're having 2√3, so it's plus 2√3 multiplied by 4√3. Minus 3 times √2, that will be 3√2, and then minus √2 multiplied by 4√3. We divide everything by 3 times 3, that's 9, plus 3, 4√3, minus 3, 4√3, and then minus 4√3 multiplied by 4√3. So where are these coming from? So we got 3 times 3 to get this 9. And then 3 times 4 root 3 is what we have here. Then minus 4 root 3 times 3 is what we have here. And then minus 4 root 3 times 4 root 3. Minus 4 root 3 times 4 root 3. Like that. So now we go back and say, okay, 6 root 3, we can't do anything to it. But here we can multiply. 2 times 2, it will be 8. Root 3 times root 3. Look what happened here. It was 12. Then we said we can write it as 4 times 3 inside the root. Later on, we separated the roots, meaning if we have root 3 times root 3, we can use one root and then do 3 times 3 inside the root, so that it becomes 9. And the root of 9 is 3. So now we're going to have a 3 here multiplying 8 minus 3 root 2 and then minus 4 root 3 times 2. Again, we can push them inside, both of them. So we push root 2 and root 3. We'll have a single root, then we'll have 2 times 3 inside. And then now we got the denominator. So there we have 9. These guys are equal and having different signs. So meaning that they'll subtract and cancel out. So we'll have minus 4 times 4, that's 16. So we get 16 times root 3 times root 3, that's 3. Okay. So now we can add anything common on top, nothing. So we just have 3 times 8, that's 24. Plus 6 root 3 minus 3 root 2 minus minus 4 root 6. And then we divide by 3 times 16, that's 48. 48 minus 9, that's minus 39. So we'll leave our answer like that. Or, yeah, because the question was just asking us to rationalize. So I've rationalized. I hope we are comfortable there. Okay. And when you feel you're not comfortable, you ask. Let's go to B. B we multiply again by the denominator. So 4 root 7 plus root 3, we multiply by 3 root 7 plus root 3. So we get the more like the conjugate of the denominator part, since we understand the conjugate better. So you change the sign of the root 3 there. So here it doesn't matter. I would have changed the sign maybe for 3 root 7. We just chose to change for a minus root 3 to make it positive root 3. But you don't change both. You just change one. So you don't have to make a mistake by saying negative 3 root 7 again minus root 3. No. I mean then plus root 3. So just change one. So we've changed the negative to positive. The other one has been maintained. And then now we multiply. So we have 4 times 3, that's 12. And then root 7 that's 7. And then plus 4 root 7 times 3. Remember what we did? Plus 9 root 7. And then plus 3. I mean root 3, so it will give us a 3. And then we divide by 9 by 7 minus 3. Why minus 3? So I've left out the middle part because I know even if I put it, it will cancel out just like this guy is cancelled out here and there. When that happens, whenever you are rationalizing. And then root 3 times root 3, remember, we're getting a 3. So now what is 12 times 7? 14, that's 84. 84 plus 3, that's 87. So we have 87. Plus 4 root 21 plus 9 root 7. And then 9 times 7, what is it? What 9 times 7? 63. 63 minus 3, we get 60. So we call it a rationalized thing there. Because rationalize the denominator means get rid of any root from the denominator.
I think I've entered the first year class.
Oh yeah, this is Q for first year. Yours is at 21. Okay.
Oh, this is
Then
for first year.
C. So for C, I'll just move it a bit for you guys, then you'll be able to finish it where I'll leave it. C. So C, 3 plus root 2, you divide by 1 plus 2 root, we can write 18 as 9 times 2. Okay, and then minus 2 root 2. So my board has ended there. So I'm doing this. Meaning we have 3 plus root 2 over 1 plus. The root of 9 is 3. So 3 times 2, it's 6. 6 root 2 minus 2 root 2. Meaning we have 1 plus 6 minus 2, that's 4 root 2. Then at that point now, you rationalize. So you multiply down by 1 minus 4 root 2, and also up by 1 minus 4 root 2. Okay, so I trust you to finish that one, since I know you can. Do you have any questions on rationalizing? Because now we're going to complex. Okay, yeah, super fine. Let's go to complex numbers now. Complex numbers. We'll go straight to examples. Okay, maybe before that, I should mention that if you are given Z, A plus BI, A is called the real part of Z. and B is called the imaginary part of Z. They are denoted like that. RE to mean a real part. IM to mean imaginary part. Okay, let's go to examples. Example, express in the form A plus BI. Part A. 2 minus 3i to the power 3. And part B, 1 plus 2i over 1 minus I plus 1 minus 2i over 1 plus 3i. Like that. Maybe let me also put this one as a bonus, 1 plus root 2i over root 3 minus 2i. Okay, so let's work out. So we have the first one. So the first one, we multiply 2 minus 3i multiplied by 2 minus 3 multiplied by 2 minus 3i. That's what power 3 means. So first do the first two here and there. 2 times 2, 4. 2 times 3, 6. 6 again. And then minus 3 times minus 3. It's positive. I times I, it's I squared. So we maintain this, and then we're multiplying by 2 minus 3. Then we come back. Say, okay, what is I squared? So I squared is equal to -1, meaning we have a -9 here. So -9 plus 4, that's -5. And then minus 12i. When we add the 6, that is 6, then we multiply this by 2 minus 3. Like that. So we have minus 5 times 2, that's minus 10. Minus 5 times minus 3, that's plus 15i. Minus 12 times 2, that's minus 24i. Minus times minus is plus. I times I is minus. So you get 12 times 3, that's 36. Okay, so we did 5 times that times this times this, and then this times. So now we put -10 minus 36, that's minus 46. And then 15 minus 24, that's minus 9i. So we have expressed in the required form. When they say express in the form A plus BI, you just need to leave it like that. We don't need to say A is equal to -46, B is equal to -9. No. You just leave it there. Are we comfortable this far? We're going to B now. You need to be responding whether you're comfortable. Let's go to B.
So I have a question.
Please ask.
So every time the answer has to have the imaginary part and the real part.
If one of them is not there, then it's allowed to become 0. So when it's 0, you choose whether to write it or not.
Okay.
Okay. So let's go to B. So B has 2 parts. You can choose to conjugate the independent ones and then put them together. Or you put them together now and then conjugate at once. The best, we put them together. 1 minus I multiplied by 1 plus 3I. Because to multiply is easy than to conjugate twice. So we have 1 plus 2I multiplied by 1 plus 3I. What's happening there? Those are fractions. Then 1 minus 2I multiplied by 1 minus I. Meaning we have 1 plus 3I plus 2I minus 6 plus 1 minus I minus 2I. I times I is negative. Negative 2 times negative 1 is positive. So positive times negative, negative 2 over 1 plus 3I minus I times I, negative, times negative plus. So it will be plus 3, like that. And then now we say, okay, 3, let's start with the constants. 1 minus 6, that's minus 5, plus 1, minus 4. Minus 2 has gone back to minus 6. React. Then 3I plus 2I, 5I. Minus I, 4I. Minus 2I, 2I. Reducing so fast. And then 1 plus 3, 4. 3I minus I is 2I. Then now we multiply. 4 minus 2I. And then 4 minus 2I. That's when now you conjugate it. So conjugation here looks like this rationalization that we are doing on the other side. The other side was called rationalizing. Here, conjugating. So negative 6 times 4, negative 24, plus negative 6 times negative 2, that will be plus 12. I plus 8I, I times I, negative, times negative, positive, 4, over 16 minus 8I plus 8I, I times I, negative, times negative, plus 4. So you see down there, what's happening there happened when you're doing rationalization. They cancel. So we have negative 24 plus 4, negative 20. And then Negative 20 plus 30i. We're dividing everything by what? 20. So we can separate now. Negative 20 over 20 plus 30i over 20. So we get minus 1 plus 3 over 2i. Remember here we are told we should express in the form a plus bi. That's why we go a step further by doing that division which I've done there.
Yeah.
Hello.
How did the 30 come about?
How did they?
The 30. 30.
Oh, 30. Oh, is it 30? Oh, sorry.
Did it come about?
This guy is actually 20. Supposed to be 20, isn't it?
No.
Yeah, it's supposed to be 20. Okay, let's go back a bit. Let me pick it from here, since I'm not getting it clearly. Okay, so we're saying negative 24 plus 4, that's negative 20. And then 12i plus 8i, that's positive 20i. Yeah. And then over 16 plus 4, that's 20. That's 20. Okay. So we're getting minus 1 plus I. This is what we have actually, which is correct now. Like that. Part C. Part C, 1 plus 2, root 2i, we multiply by root 3 plus 2i. The conjugate from the denominator. That. Okay, 1 times root 3, 1 times 2i, then root 3 times root 2. Remember what we did? It will be root 6, I outside. And then I times I, it will be negative 2 root 2 I over root 3 by root 3, 3. And then 2 times 2, 4. Remember, I'm skipping the root 3 times 2 because I know it will cancel out once we are doing the conjugation. So it goes straight to 2 times 2, which is 4. I times I, negative 1, times the negative that is there, it becomes plus 4. So now we rearrange. So we have, oh. So look at this, the root 2i times 2i needed not to have the I. So the I is the one that gave us a negative. So this part is not there. Yeah. So now we'll write it as root 3 minus 2 root 2, the ones without I, over 7 then plus 2 plus root 6, and then the I is written outside like that, over 7. So we put it like that. Okay. That was question 8 in the tuition. So today I'll give you exercise. The exercise will be exercise. Will be question 9 of sheet 1. We're doing 9B and 9D. Yeah. So you do 9B and D. And remember that you always have to submit. I always check. If I'm quiet, it's correct. If you're wrong, I'll respond. So slowly you're preparing for a quiz. Next week, there's a quiz on Saturday for 1100. Meaning that for 1120, it's either on Saturday or on Sunday. Next week. Not this weekend, but the other weekend. On 13th, there's 1100. Meaning that on 13th or 14th, there will be 1120. So this is how we get to preparing for the same. Draw sheet 1. When you do that exercise, we'll come back and polish up, and then we'll start to look at draw sheet 2. So we'll keep moving like that, slowly but sure. Okay. Bye-bye. I need to teach the guys for 2100 before power cuts.
Excuse me, sir. How do I get access to tutorial sheet 1, Math 1120?
Somebody will send it in their group, even in tutorial sheet 2.
All right, thanks.
All right.